Alright, guys, we are back, and today we are going over the severe threat tomorrow. We got an enhanced risk, the 10% hatch tornado risk for central Missouri and southern Illinois, as well as a really broad 5 and 2% that extends through much of the lower southern plains and then into the eastern Midwest, even all the way over to Appalachia. So, got a big wind risk, 30% significant wind risk, with a 15% wind risk through much of the same areas, and a significant hail risk. That's really centered on the portions of eastern Oklahoma and western Missouri. We have a day 2 outlook where we have another enhanced risk. Now, we don't have the tornado and the wind probabilities yet, but they have a 30% probability of significant severe over here in the portions of central Appalachia, eastern Texas, southern Ohio, and western West Virginia. As well as we have the slight risk that extends all the way down into northern Mississippi, all the way through the central Tennessee valleys and northern Alabama. And we have a really large marginal risk that extends all the way and encompasses the entirety of Mississippi, Alabama, as well as the northern corner of Georgia, all the way up through the Midwest into the Northeast. So, really big, broad risks for both of the next 2 days. And we're going to get into that. But first, what I wanted to do is pay a little bit of homage to the 1 year anniversary, since we're making this video on March 31st. This time last year, we were preparing. We had just got the notification that March 31st was going to be upgraded to a high risk, 5 out of 5, the highest risk you can possibly issue for severe weather for portions of central Iowa or eastern Iowa, western Illinois, as well as portions of eastern Arkansas and much of the northern third of Mississippi. And they had a 30% tornado risk, one of the highest. It's upper echelon of the scale of possibility of violent tornado risk. Had a really large damaging wind risk and a really large hail risk too, all the way through the entirety of the eastern portion of this risk. And this was a really large risk. This is one of the largest I had ever seen, where it took up much of basically a third of the United States. And how did that verify? Well, it verified pretty well. As you can see, all these unfiltered tornado and wind reports, all these red dots are tornadoes, and they pretty much nailed it. As far as the storm starting over here, you got some notable tornadoes, including the one in Little Rock, and then you got the ones in Wynne, Arkansas, and Covington, Tennessee. Also, that was a EF3, and then the Hardin County EF3 that came through overnight, and also filtered. Also, some tornado reports down here. If I remember correctly, I think Guntown had a tornado, as well as Golden, Mississippi had a tornado. There were tornadoes all throughout the night. This was one of those days where you could see from even 6 to 7 days out that this was going to be a big day. All the ingredients were there. Everything had just come together almost perfectly, and you knew it was going to be a bad day, and it was. So, really good job by the forecasting team. Even up here, given how broad this risk was, you had your Keota EF4 that was over here in this vicinity, right in the middle of the high risk, and you had unfiltered tornado reports all throughout the risk. It was the third largest tornado outbreak in recorded history. The only two that beat it were the April 27th, 2011 super outbreak, and then the 1974 April 3rd and 4th super outbreak. So, this is a day that'll live in infamy for a long time. A lot of lives were lost, and then a lot of people lost their homes, so a lot of reverence that needs to be dealt for such an impressive day. Yeah, hopefully we won't see anything like that anytime soon again. It's about as close to a super outbreak as you can be without being one, but which we were surprisingly low on the violent tornado count, which we only had that one EF4 up in Keota. But as I said, there was over, I believe, 140 tornado reports total, or 169. I'm sorry, 169 total tornado reports. And as I said, it's the third largest outbreak in recorded history, dating back to the 1950s when we started keeping record. So, just wanted to pay a little bit of homage to this and a little bit of weather history, especially for northern Mississippi, as we lived through it last year. And we'll go ahead and jump back into the tomorrow's risk for the plains and Missouri River Valley, as well as the Midwest and Eastern Tennessee valleys going into Tuesday. Let's see, go ahead and give you a look. This is the 500 millibar map. Currently, this is observed, and you can see this big positively tilted trough just looming off the coast of California. And very strong belt of flow. It's hard to tell. I'm hoping y'all can make it out. But you have a stronger belt of, it looks like 80 to 90 knots of flow rounding the base here. And it's gonna remain pretty much positively tilted. It's just gonna continue to work into the region of the Central Plains and Missouri River valleys. We'll go ahead and take a look at the models. As right here, we can start off at the HRRR. Now what we're going to do is we're going to take 3 different models, short range models, to go over tomorrow. And then we're going to take some of the slightly longer range models so we can get a look at Tuesday, because it's not yet in range for us to be able to look at the models for Tuesday. The short range models, at least, we'll take a look at the NAM and probably the GFS to take a look at Tuesday. But we have enough convective allowing models for us to quickly go over this plains and Midwest type of event. And you can see, just like we saw in the observed data, you got this broad positively tilted trough working its way in. And that is forecast to really take on, you get kind of this vorticity maximum. You see this enhanced belt of 100 to 110 knot flow. You can see this sort of inverted trough. It's a negatively tilted shortwave, and it's really slingshotting itself in. As you can see, this surface cyclogenesis or upper level cyclogenesis on the east side of the Rocky Mountains start to take shape, and you really get this it kind of whiplashes this negatively tilted little shortwave into the region, and it really impedes on the region right as the go time occurs, right at 7 p.m. on Monday. So you get maybe a little bit of divergence. You get a little bit of spreading apart of the wind vectors right here. It's a lot less amplified than we originally thought. We originally thought it was going to be this really big upper level low attached to this short wave, and it was just going to eject a really strong belt of 100, 110, 120 knots of mid-level flow into the region. And then we would really be talking about problems. But nevertheless, we still do have that negatively tilted shortwave. It's just a lot less amplified than it was when we looked at it a couple of days ago. But as that moves in, you really do start to see a little bit more of that divergence aloft. Especially, you see you got winds going really out of the south here in western Oklahoma, and then toward Arkansas you got them really out of the west. So a lot of spreading apart over here that's going to promote some large-scale lift. And we're going to go ahead and pause it right here at 36 hours. And that way we can kind of take a look at the other models and see how they process this trough coming in. So we're jumping over to the NAM, get this negatively tilted trough, and it does really rotate. You can see it does something similar, maybe a little bit stronger of a shortwave. Ejects its way into the region. Maybe a little weaker on the cyclogenesis, but you do get that stronger belt of flow. Not quite as much divergence because you got a weaker upper level low. As you see, you don't see the closed contour. Alright, this is 42. So let's take a look. And compared to the HRRR, you can see maybe a little more consolidation of the upper level low versus the NAM, where you don't see that closed contour, and it looks a little bit more progressive, maybe a little bit more off to the east, but still a lot weaker, and you don't get that that stronger divergence aloft. You just get really broad southwesterly flow all the way throughout the region. So let's take a look at the RRFS. This is our other convective allowing model. And as we work our way in, I mean, they're on the same page as far as this negatively tilted shortwave. that stronger flow rounding the base. Maybe a little bit of a closed contour. There is a resemblance of some divergence, but relatively not much to speak of as far as strengthening trough. We can compare it to the NAM. It's pretty much on the same page as the NAM, with maybe a little divergence, but mostly just southwesterly flow coming all throughout Oklahoma into the region. And the HRRR is probably the most dynamic, I would say, or strong on that surface cyclone. But relatively the same picture. Maybe a little bit weaker, discombobulated flow where you got little gaps of 60s and 50s. It's not as, which that might just be a model quirk, as you get pretty much, the broad consensus is you're going to get 70 to 80 knots of flow rounding the base of this trough as a negatively tilted shortwave ejects into the region. We're going to look at the HRRR and the 850 millibar height, and what we're looking for is that surface cyclogenesis on the lee side of these Rocky Mountains. We're looking to see a resemblance of a surface low that's going to be able to pump winds out of the south and to really veer and back those low level winds. So you get that turning in the winds with height, and that gives you your tornado potential and also some of your damaging wind potential. So going into the evening on Monday, we get maybe a little resemblance of a low level jet, right here at 0Z, right at storm time. Not much. I mean, there's a huge gap. It's a really weak. We don't really see a consolidated cyclone over here. So really just broad. It looks like a really broad cyclone that's really not pumping the winds out of the south that we'd like. You still get a 30 to 40 knot low level jet, but it's really weak and it's got patches and it's not consolidated yet. Now it really, as we hit that overnight period, that's 8 to 9 p.m., we start to see an uptick over here in the Ozarks of a low level jet, but it is a little bit veered. Really not this strong belt of 40, 50, 60 knots that we like. Got to think the risk is right in through here. Now you do get a little bit of it, but it's really not as tight, and it's really more conditional, at least from what the HRRR is showing. Let's stay at 1Z, and let's jump over to the NAM and see how it renders the surface cyclone. We got a little bit of a resemblance going into tonight, into tomorrow. Maybe a little bit. Here we go. And here's the surface cyclone. You see a little bit of a closed contour right here, but really much of the same. You don't really get a strong, you want to see closed contour inside a closed contour as it comes across, and it's still pretty broad and discombobulated, and you get this stronger belt of flow to the south, but it's really, straight out of the west. You would want to see this more southerly going, like these wind barbs. You'd want to see them more out of the south, or maybe southeast, but preferably south, and you get them straight out of the east coming into the warm sector. Which our area of interest is right in here. If you want to look in the bottom right, I got the date. This is for Monday, April 1st. And it's really just discombobulated. Maybe a little maximum up here on the warm front, which would make sense why they have that 10% hatched over there, as the warm front does tend to increase low-level shear along that differential heating boundary. So up here on the warm front, which we'll go over once we get into the dew points, and with a gradual uptick overnight as we go into the next day. So, and the surface cyclone really never consolidates. It just stays broad and just meanders off to the east. So let's go ahead and 43. So similar story. Let's go ahead and check out the RRFS and see what it kind of works into. So we start to get, it's just no resemblance of a surface cyclone at all. We get this low-level jet, but it's really weak and patchy and just not consistent. Except up here by the warm front. And you get this kind of just really broad, discombobulated surface low that doesn't really strengthen and back those winds in the lower levels, except up here by the warm front, right here along that Missouri boot hill into that Illinois. So that makes sense why they have that 10% hatched risk up there in the Missouri and Illinois area. Let's go ahead and go to 1 and compare the locations. 1 second. There we go. Alright, so on the HRRR, you can see that. And compared to the NAM may be a little stronger, but it's really the outlier. You do get that strengthening on every model, especially off to the east. So a concern would be if storms were able to fire over here in eastern Oklahoma and then continue to track east, and as long as they remain relatively organized, which they shouldn't have a problem because of the moisture that we're going to have in place. If they can continue overnight as this low-level jet ramps up, depending on the orientation of the cells or the line segment, it could have an isolated tornado risk along a QLCS, considering the ramp up of the low-level jet. But you're going to need some surface-backed winds to really make that a reality. Alright, I'm going to start rapid firing this so we can get into the Tuesday risk. Really diffuse dry line right here in central Oklahoma, and you get that big, strong moisture that's really being transported up north, and that's been transporting north, and it's already in place. So this is on the HRRR. You got 70s dew points all the way up to near the Red River, as well as upper 60s dew points all across the region, all across the warm sector. So anything that can fire and maintain is going to be able to maintain itself overnight. And then same little bit more bullish dew points, as you can see, upper even 71, 72 dew points all the way up to the Red River. And you get that deep, rich moisture along with your diffuse warm front, even a triple point right here with your warm front, with your cold front back here, and then your dry line right here. So with a little bit, maybe a little hint of a dry line bulge, so it wouldn't surprise me at all to get storms to fire right off the dry line. And then along the warm front as well, right in front of the warm front along that differential heating boundary with that greater low-level shear is the reason that they have that enhanced tornado risk up here in this region. The RRFS, same thing, bullish. It's pulling those 70s up past the Red River into southern Oklahoma, but really weird and diffuse dry line. I noticed this on models last night. The NAM is really bullish on that cut dry line, but the HRRR and the RRFS are really just messy and disorganized with the dry line. So it's gonna, but that's due to that surface low and the way it's not consolidating and continuing to move east. So I would tend to buy the RRFS and the HRRR over the NAM. But regardless, you still have this wide open warm sector all the way up to the warm front, and you got your enhanced tornado risk up here. So, alright, taking a look at the composite reflectivity. Just to get an idea of how it renders it. It's got, along the dry line, it's got some discrete to semi-discrete supercells along this diffuse dry line that really fire, and maybe multicellular, not quite supercellular, but you get some supercells down here by the Red River and that better moisture. And you get some, possibly some supercells up here along the warm front that track due easterly before congealing into really a mess up here along the dry line. And then you get these cells that continue east, and maybe continue east to be a little bit more discrete as the shear vectors are a little bit more perpendicular to the initiating boundary, whereas at the dry line they're very parallel, so they're going to be a lot more likely to go linear up here to the north. But down to the south, you might have a period where the HRRR really keeps them discrete overnight. And what could happen is, as these track overnight and that low-level jet ramps up, especially as it gets in here into the Arkansas area, you could see maybe a little bit greater of a tornado risk overnight into the areas of the Ozarks, the northwest and the southwest portions, really the western half of Arkansas, as these cells progress overnight, if they can remain discrete. So that would be a slightly more of a higher end concerning threat. But let's take a look at the NAM and see how it renders it. So the NAM Similar solution is you get these cells that fire up along the dry line, but you got to think the NAM has a lot sharper of a dry line, as you can sell this just arc of supercells that work their way through and remain relatively discreet, but they seem to fizzle out as they get into the overnight period. And up here in your target risk area, the NAM isn't really, it's really pushing that convection off to the north of the warm front. And it's not firing much along it that's sustaining itself. Maybe these up here, maybe these, but that would, in my opinion, have more of a elevated hail risk. I might just throw out the NAM in general as a solution, just because of how much of an outlier it is. Now over here, as you go into 23C, you get that same arc similar to the HRRR. And you get this arc, and that kind of turns into a bowing segment as it moves east. That would foster definitely a damaging wind risk as well as a tornado risk on the tail end. And you get this secondary arc that fires well into overnight, and you have this really strong line of convection that forms along the warm front up here that really tracks east along the warm front. And you can see these updraft helicity tracks. It's picking up these increased areas of rotation just along the warm front, so definitely could foster some tornado threat, especially if they're remain somewhat sort of discreet. The line orientation moving due easterly, and if you can get any semblance of some backed winds, definitely could foster that 10% hatch tornado risk that's been outlined. But as soon as these cross north of the warm front and enter that worst moisture, they'll eventually become elevated and turn just into hailers. But down here in the open warm sector along the dry line, this seems to continue, and it holds the strength. This could, if this rendition was to come to reality, this could foster more of a tornado threat overnight, especially as we get into that midnight time frame, as they continue to traverse into good moisture. Terrible radar coverage in this area too, and you get that low-level shear that gets enhanced, as well as these cells that fire off to the west overnight. That could be an issue as we go into the overnight hours. But as of right now, the 10% tornado risk would be for these cells that fire and train along the warm front up here in central Missouri and southern Illinois before they cross it and become hailers. And then you got your damaging wind and hail threat for any cells and line segments that can form down here along the dry line. And as they move east overnight, if they can maintain themselves, might have an increased tornado threat as they get into the central Ozarks in northern Arkansas, as well as any of these cells that can maintain themselves and mature overnight. So I threw out the NAM model. We're just going to go through the HRRR, and we'll go over the SIGTOR just to give you a consolidated area of where the highest potential for tornadoes are before we transition into Tuesday. Okay, here we go. We are on the HRRR, and as we go into the evening, you can see a really nice uptick over here along the warm front. That's what that 10% hatch is for. And we do have an increase of the significant tornado parameter down here in the southeast Oklahoma into the Ozarks. You get a really sharp area for that secondary area of convection that fires along the dry line. So you got some increased values over here in the southeast portion of Oklahoma and eastern portion of Arkansas. That continues overnight as that low-level jet ramps up. So definitely maybe some increased tornadoes probabilities, especially over here in the eastern Ozarks. Terrible chasing terrain as well as difficult radar coverage. So this is going to be something you need to really watch out for warnings. And then let's see. And then over here on the RRFS, you get that consistent enhanced area over here along the warm front. And then you get that same general vicinity. You get that Red River over the Dallas-Fort Worth area. It kind of ramps up and then transitions east into the Ozarks as we go overnight. So definitely possibly some tornado potential with these in the southern mode. We'll just have to watch trends and see how that low-level jet shows itself going into the evening. But as of right now, that seems to be your main threat. And right now, what we're going to do is I'll go ahead and show it to you again. We'll shift to Tuesday's threat. And what I'll do is I'll show you the NAM and the GFS. So, like we said before, we got that enhanced risk up here in the northern mode, but we're really going to focus on the southern mode just because that's where most of our viewers are located, and we've already spent a lot of time on this video. So, we'll do a quick overview on the southern mode. Alright, so we got the NAM and the GFS right here. This is the NAM solution. This will be right at showtime. This will be the evening of Tuesday. And as this trough continues to progress east, you still got this broad positively tilt, but this short wave that was negatively tilted as it impacted the eastern southern plains and then the Missouri River Valley it's kind of sheared out and flat. And this will this isn't as favorable as of a significant severe type of a setup as you get this extremely veered winds. You get this almost clockwise turn here at the northern mode. But pretty much the main story is you get broad southwesterly flow under the base of this trough with 60 to 80 knots of flow. All the way throughout the region, you get this strong belt of 80 plus knots. And then on the GFS, a little more compact. You can see maybe this negatively tilted shortwave a little more. You can see a little bit of diffluence up here in the Midwest. But the same general story through the southern portions of the Tennessee Valley as you get this just broad southwesterly flow. Alright, and on the NAM, you get just a little more resemblance of a low-level jet. You have a really broad, just 40 to 45 knots of a low-level jet. However, it's very much in the same direction as the 500 millibar maps. It's coming out of the same direction, so there's not a lot of turning with the winds and height. Unless you get a strong surface response out of the south, this really promotes more of a damaging wind threat, is that this really promotes downdrafts and where the wind will undercut the backside of a storm and really promote linear development. And that'll mix some of the stronger winds aloft down to the surface. So whenever I see mainly straight line winds like this, if I was to look at a hodograph, they would be pretty much straight lined. And that really sends off alarm bells for damaging winds for me. As far as the 850 millibar on the GFS is a little more potent. You get a little more out of the southwest that extends all the way down here through the risk area. You get that 35 to 40 knot jet in here, the southern Tennessee Valley, and then it increases up here to a 50 knot low level jet up here in the Midwest, where that enhanced risk is currently placed over here in eastern Kentucky and southern Ohio. So that would be a much more, you can see the consolidated surface cyclone. You get a little more stronger southwesterly flow. And that would promote much more of a significant severe type of hazard. But once we get into the convective allowing models, we won't have to use the GFS. We'll get a lot better resolution. Alright, coming down to the dew point, looking at the NAM, and still, I mean, you got the broad lower 60s, lower to mid 60s up here in the Ohio Valley, and you got upper 60s, so you got 66, 67, all the way along this cold front that's coming through, and it's going to be crashing southeast. So, moisture's not a problem on the NAM. You got a wide open warm sector here. And on the GFS, much of the same. A lot more bullish on the moisture as you get 69 to 70 dew points all the way down here in the southern mode, and all the way up through the Tennessee Valley you get upper 60s. So a little bit bullish on the moisture from the GFS, but definitely either way more than enough. Alright, taking a look at instability, and you can see this maximum of 2,500 joules, or 2,000 to 2,500 here in that enhanced risk area. But down here you got 1,000 to 1,500 joules just chilling in eastern Mississippi and northern Alabama. So instability is not going to be an issue for storms to fire and be able to mature over here all throughout the risk area on the NAM. And the GFS is surprisingly a little more muted with the instability. I kind of expected it to be a little more intense, but this is a global model, and they don't do as good of a job as resolving instability. However, you do get that a little bit higher here in the southern area of northern Mississippi and Alabama, where you get that 1,500 upwards of to 1,800 joules per kilogram, right along that cold front. And up here, you do get some resemblance, more than enough. Likely, it's being underdone by the GFS, but you will get instability. And let's see. Let's take a look at the energy helicity index. And this is just a combination of the low-level shear and the instability. And you get enough, especially up here in the outline enhanced risk area, but you get enough along the line here where there's just enough shear. Cut that. Alright, and on the NAM, you do get just a little bit of low-level shear, not a lot. You got to think the cold front's extending somewhere along here. And on the eastern portion down here in the southern mode, you just maybe 150 meters per second squared. But over here in the outlined enhanced risk area, you definitely get those higher 300 plus values of storm relative helicity. So down here, maybe not much of a tornado threat, possibly a significant hail threat and a damaging wind threat. However, over here, I would expect to see your increased tornado risk. Let's see if that changes as we go into the evening. And you do get this increase down here in the southern mode, but let me see it. Let me see if I can see it in relation to the cold front, because usually behind the cold front you would get a little bit more enhanced helicities. Let me go to the dew point and see if I can pick out the cold front. Yeah, so it's already passed, and that little area right behind it's just that change in wind direction. So you would really be looking down to the eastern portion, the really eastern portions of Mississippi, and northern Alabama would still be under the gun. But going back to take a look at the storm relative helicity, yeah, so don't buy these bright colors right here. You're looking right here is what you would be making your forecast off of, and you don't get much. So let's take a look at the bulk shear vectors on both, just to see, since we don't have the convective allowing, we can kind of speculate how our storms are going to fire. And very much perpendicular, or parallel, I should say, to the initiating boundary. Our initiating boundary is somewhat right here, and it's very much parallel these wind barbs are. So the initiating boundary is right here, and the wind barbs are going just like this along it. It's really parallel. So that tells me we'll likely get a line of storms develop along this cold front, as we have enough forcing due to the cold front, and they'll be able to track probably southeast along this cold front as it pushes southeast, and with damaging wind and possibly some hail is what I would be expecting for Tuesday. And very much the same thing on the NAM. At least they're starting to consolidate in on a location, so I would expect a line of storms to probably develop early to mid-afternoon over here along the Memphis, St. Louis corridor, and then just track southeast and continue to pick up steam as it goes through the evening, and then ingest that favorable instability and low-level moisture. So as of this time, I think we're going to go ahead and leave the forecast off here. Do one more quick overview. This is the risk tomorrow. You got that broad enhanced risk with that 10% hatch tornado, 30% wind, and 30% significant hail. Then this is for Monday. And then for Tuesday, you got this enhanced risk with 30% severe probabilities up here in the Ohio Valley and western Appalachia, and with the 15% that extends all the way down into northern Mississippi for that damaging wind and hail threat. So as of right now, we're going to end that video off. Probably won't end up doing a video tomorrow. Probably won't end up chasing either of these setups, because the active pattern looks to continue over the next couple of weeks, and I want to be able to save my resources so I can get out and chase those bigger events. But these definitely need to be taken seriously, especially if you live in any of the outlined areas. And yeah, we'll get through it together. And I'll probably be chasing the next portion of events, which at this point seem to be around the eclipse, sometime in the April 7th through 10th type of category is when we think we're going to see our next bout of storms. But for right now, we've covered all this, and we'll get through it together, guys. We are in mid-spring, and yeah. So appreciate you guys watching. Y'all stay safe. Make sure you have a way to get warnings, and I will see you guys in the next